So it turns out there's a lot you can do with complex numbers. And as you head into your pre-calculus and your calculus, you're going to want to know those things. Plus, I'm going to be honest, from what I've learned, you use these complex numbers in engineering applications, you use them in video game design applications. They're all over the place. So I want you to know a little bit more about what complex numbers are and how you can work with them. Let's start with this. How do you graph a complex number? The issue is you can't put it on a number line because a number line is one-dimensional, and complex numbers have two parts, the real part and the imaginary part, so you need two dimensions. Complex numbers are graphed as points in the plane. Now, we set up two axes. On the horizontal, or the x-axis, you're going to have the real part. And then the y-axis, the vertical, is the imaginary part. So a single complex number is a point in this, it's called the complex plane. So to graph something like 2 minus 3i, you start in the center at 0, 0. Your real part is 2, so you go over 2. Your imaginary part is minus 3i, so you go down 3. This point is the complex number 2 minus 3i. Okay, so take a moment. I want you to imagine what the graph of 2i is going to look like. So really, it's like 0 plus 2i. So you don't move left or right at all, and then you move up 2 spots. There's 2i. Negative 3 plus I. Again, take a moment. Imagine where you think it's going to end up. So the real part's negative 3. The imaginary part is plus 1i. This point right here is negative 3 plus I. And then lastly, real numbers can be graphed too because they just have an imaginary part of 0. So I'm going to move 4.5 spots to the right and then just not up or down at all. There you go. So complex numbers are points in the complex plane, ordered pairs. Okay, then, what does it mean then to talk about the absolute value of a complex number? Absolute value, you may need to think back to your middle school days here. Absolute value measures the distance from 0. So as I look at this first complex number here, this is 0, the origin. The distance from 0 is the length of that diagonal line. So what does it mean to find the absolute value of a complex number? It means to find the length of the diagonal from the origin to that point in the complex plane. Don't overcomplicate it. It's just Pythagorean theorem stuff. Because you can always make a right triangle every single time, where you're going to have an A distance on this side, that's the real part, and a B distance on this side, that's the imaginary part. So let's take a look at this particular example. The black point that was originally graphed is negative 2 minus 1i. That's what this black point was. The absolute value of this is then going to be, well, let's think about it. I'm going to find this length here. I'm going to call that C. So let's just think for a moment about how this is going to work out. A squared plus B squared equals C squared. That's your Pythagorean theorem. So C is then just the square root of A squared plus B squared. That's how you find the absolute value of a complex number. So in our example, the A is negative 2. The B, now it's not I, it's just the number in front of the I. So negative 1. And then let's simplify. So that's going to be a 4, that's going to be a 1. So the absolute value of this number is square root of 5. And again, that comes from that Pythagorean theorem. Here's what I want you to do. I want you to try this next one. So do a pause, identify the number, run through the process. Let's see if we get the same answer then. Okay, you better have paused and tried this already. First, the number, it's going to be 4 plus 3i. So I'm looking for the absolute value of 4 plus 3i. That's going to be the square root of 4 squared plus 3 squared, which is the square root of 25, which is just 5. So this length from the origin, so from 0 to that complex number, has a length of 5, and therefore that's the absolute value of this number.